When we first investigated how to calculate a consumer's optimal consumption bundle in Chapter 6, we set up a constrained maximization problem. The consumer maximizes her utility subject to a fixed budget constraint. Now in Chapter 7, we're trying to distinguish between substitution and income effects. And in calculating the substitution effect, we set up a constrained minimization problem. The consumer minimizes her expenditure subject to staying on a fixed indifference curve. In this set of graphs, we will illustrate how this mathematical formalization translates into graphs. We begin with the constrained maximization problem from Chapter 6, where we have a fixed budget constraint within which the consumer must stay. We then illustrate an arbitrary indifference curve that intersects that budget constraint and ask how much better the consumer can do. Maximizing utility for this consumer means trying to reach the highest possible indifference curve given this budget, so the consumer will keep shifting to higher and higher indifference curves so long as there's still some points along the indifference curve that remain in the budget. She'll end up at the green indifference curve and at the usual point of tangency. This gives us the constrained maximum, which is the solution to our optimization problem, a solution where, so long as it is an interior solution, the marginal rate of substitution is equal to the slope of the budget constraint. This is, in fact, exactly what the first order conditions of our optimization problem tell us. Now let's turn to our constrained minimization problem, where what is fixed is the indifference curve, not the budget constraint. This is useful for finding the substitution effect, because substitution effects happen along a fixed indifference curve. We now start with an initially high enough expenditure level such that the budget created by that expenditure level intersects the indifference curve. We then ask how much cheaper it could be to reach that same indifference curve by removing income or expenditure from the consumer until we get to the usual point of tangency. We have then reached the smallest possible budget that will allow the consumer to reach this fixed indifference curve. This gives us the constrained minimization of the problem. In other words, the bundle of goods that allows the consumer to reach this indifference curve at the least cost possible given the prices for the goods that are incorporated in the slope of the budget constraint. Notice that once again, the marginal rate of substitution is equal to the slope of the budget constraint, just as it is in the case of the constrained maximum. This is again exactly what the first order conditions of the mathematical problem tell us. We write this problem out mathematically by saying that we'd like to minimize the expenditure E, which is just equal to the price of good 1 times x1 plus the price of good 2 times x2, by choosing x1 and x2, subject to the constraint that our utility level must be equal to a certain number, the number which is the label on the fixed indifference curve. The Lagrange function for this optimization problem is then set up as it always is in an optimization problem. We begin with the objective function, which in our case is E, or 0.2 times x1 plus x2, given that the prices are 0.2 for x1 and 1 for x2. Then, this is followed by a lambda term times the constraint set to 0. Notice that here we're using a utility function that is Cobb-Douglas with exponents of 0.1 and 0.9. We can see then that our two optimization problems are mirror images of one another, and which one we use depends on what we're trying to find. If we're actually trying to find what the consumer does given a fixed budget, we use the problem in panel A. If, on the other hand, we're trying to find out where the consumer would choose to consume were she to stay on a single indifference curve, which is what we're trying to do when we isolate a substitution effect, then we use the problem in panel B. In either case, so long as the solutions are interior solutions, we end up at a bundle where the marginal rate of substitution is equal to the ratio of the prices. When we complete our analysis of basic consumer theory in Chapter 10, we will see further evidence of this mirror image between the constraint maximization and minimization problems as captured in what is known as duality.